Hi all. So this is SEM 2 P1 semester 2 unit 1 system of particles and rotational mechanics. This is an exercise problem. A non-uniform bar of weight W is suspended at rest by two strings of negligible weight as shown in figure. This is the bar. Its weight is W. It is suspended with two strings, string 1 and string 2, and whose masses are negligible when compared with the weight of the bar. The angles made by strings with verticals are 36.9 degrees and 3.1 degrees. The string 1 made with rigid support with vertical 36.9 degrees, and this is the string 2 made 53.1 degree is vertical. This is another rigid support respectively. The bar is 2 meters long. The bar is 2 meters long. Calculate the distance d of the center of gravity of the bar from its left end. So this is the point what we call center of gravity. Center of center of gravity. Let's say C. So we have to calculate the distance from left end to center of gravity. This value would be. So what is center of gravity? The center of gravity is like a center of mass, an imaginary point. We can assume whole weight of the body, assume it to be acting at this point. At this point, such a point is called center of gravity. Center of gravity. So we have to calculate the distance, this distance from the left hand to center of gravity. Left hand to center of gravity. So here we have to use some principle, that is equilibrium of rigid body. Equilibrium of rigid body. What is equilibrium of rigid body? So there are two conditions to satisfy for satisfying rigid body equilibrium. One is net external force acting on the rigid body is zero. Here the rigid body is this rod. This rod is called rigid body, right? And the net torque acting by the net external force, or all the external forces which are acting on the rigid body, must be zero about any reference point. So we can take a reference point at anywhere on this rigid body. It is our option. So there are two conditions to satisfy the rigid body equilibrium, that is sigma f bar is 0, sigma dou bar is 0. Now we have to go back. Free body diagram for the rigid. This is a free body diagram. Free body diagram. So this is the rod. There are three forces acting on the rod. One is the tension in the string 1, that is the left string. Tension in the string 2, that is right string, and its own weight which is acting on at a point on the body, that is called center of gravity. That is called center of gravity. So the weight is, it is the own weight of the rod which is acts on the rod at center of gravity point. So the tension in the left string is T1, and this makes 36.9 degrees with the vertical. So as per geometry, take this is theta 1, this is also equal to theta 1, and here the tension in the right string makes 53.1 degree with the vertical, take it is theta 2, and as per geometry this is equal, it is very clear, it is equal to theta 2. So the tension has two components. One is x component, take this is a positive y and this is a positive x. So it resolving into two components, along y and along x, along y and along x. Since it makes angle with the vertical, so vertical component of T1 is T1 cos theta 1, Horizontal component of T1 is T1 sin theta 1. For tension 2, vertical component is T2 cos theta 2 and the horizontal component is T2 sin theta 2. So now use, since the body is in, so it is clear that theta 1 is 36.9 degrees and theta 2 equal to 53.1 degree. There are two conditions for satisfying the rigid body equilibrium, that is sigma f bar equal to 0 and sigma tau bar is equal to 0. First use sigma f bar equal to 0. If sigma f bar is 0, there must be all components equal to 0. So that is sigma fx is 0, sigma fy is 0. So we use for sigma fx equal to 0. What are the forces acting along x-axis on the rod? Such as, that is, one is T2 sin theta 2 along positive x direction, T1 sin theta 1 along negative x direction. So there are only two components of forces acting on the rod along x direction. So some must be equal to 0 for satisfying the static equilibrium, rigid body equilibrium. That is minus T1 sin theta 1 plus T2 sin theta 2 equal to 0. That is T1 sin theta, from this equation T1 sin theta 1 equal to T2 sin theta 2. Now bring this theta T2 to the left and sin theta 1 take to right. Therefore T1 by T2 equal to sin theta 2 by sin theta 1. So what is sin theta? Sin theta 2, that is 53.1 sin by 36.9 sin, that is equal to 1.3318 something, that is 1.33. Okay, use sigma tau equal to 0. Second condition, torque. Calculate the net torque about center of gravity. We can use any reference point, left hand or right hand or center of gravity, but for simple calculation we have to use center of gravity. That is, we know that what is torque? Tau bar equal to r bar plus f bar. R is a distance from reference point to line of action of force. Magnitude of torque equal to rf sin theta. What is theta? Angle between r bar and f bar. There are three forces acting on the rod, that is its own weight, T1 and T2. Since we are taking center of gravity as a reference point, so the torque due to this weight is 0 because lever arm r equal to 0 for this weight, because the line of action of force passing through the reference point r is 0 for W. And where T1 makes some angle, this is a T1 line of action of force. So it resolves into two components, T1 cos theta 1 and T1 sin theta 1. The component of T1, that is T1 sin theta 1, is passing through the center of gravity. So the torque due to this component is 0 because r equal to 0 for this. But here T1 cos theta 1 is a normal component to the D, that is r. This is equal to r equal to here d. For this r equal to d and theta equal to 90 degrees because this component is perpendicular to the lever arm, perpendicular to the r. So we can use T1 cos theta 1 into r, that is into sin 90. Sin 90 equal to 1. T1 cos theta 1 into r, torque due to this component of force. Since r equal to d, this is equal to T1 cos theta 1 into d. So this is the magnitude of torque. But this force caused to rotate the body in clockwise. So the torque due to this force is negative because it can rotate the rod in the absence of all forces in clockwise direction. So that the torque due to this component of T1 cos theta 1 is negative. So that is equal to minus T1 cos theta 1, r is replaced by d, and sine of 90 equal to 1. That is This is a torque due to T1 cos theta 1. And similarly, torque due to T2. Again, T2 resolving into two components, T2 cos theta 2, T2 sin theta 2. Again, this component of force passing through the line of action of force passing through the reference point. So for this also R equal to 0. And this is R for T2 cos theta 2. And this is at normal to line of action of force. So again here 90. R equal to 2 minus D. This is equal to D. Whole length is 2 meters. Yes, the remaining length is 2 minus D. And here also 90 degrees. Theta equal to 90 degrees. So R bar plus F bar. RF sin theta. R F sin 91. But F is T2 cos theta 2. R is 2 minus D. But in the absence of all forces, this component of force can rotate the rod in clockwise direction. So the torque is positive. So torque due to this component of force. Here F is T2 cos theta 2. R is 2 minus D. Theta is 90. Sin 90 equal to 1. For this F is T1 cos theta 1. D is R. R is D. And since it is a clockwise torque, negative. Since it is a anti-clockwise torque, positive. From this equation, we have T1 cos theta 1 D equal to T2 cos theta 2 2 minus D. This brings left, and this cos theta 2 is also brings left. T1 by T2 cos theta 1 by cos theta 2 equal to 2 minus D, and D brings to right. Right. 2 minus D by D. Now substitute all these things. T1 by T2 we have already calculated in the previous equation, that is this one, into that is equal to cos theta 1, that is 36.9 cos by 53.1 cos. This is theta. Again 1.33. So this is equal to 1 point. This value equal to 1 point. 1.33 equal to 1.774. And the 2 minus D by D. 2 by D, D by D. This is equal to 2 by D, T by D. That is 2 by D minus 1. So now 2 by D equal to 1 plus 1.33 into cos 36.9 by cos 53.1 degree. That is equal to this value. That is equal to, this is equal to 1 by T2 into cos theta 1 by cos theta 2 plus 1. This value 2.774. Therefore this is equal to 2 by D equal to 2.774, but D equal to 2 by 7.774. 2 by 774. This becomes 0.72 meters. D, that is from left hand to center of gravity, equal to 0.72 meters. Thank you. Subscribe this channel.